I investigated. It seemed at first a new kind of invisible light. It was clearly something new, something unrecorded. There is much to do. These were the words of William Röntgen about X-rays when he first observed it. In this video, we will see what are X-rays, their properties, the method of production of X-rays by Coolidge tube, and their various applications. X-rays were discovered by William Conrad Röntgen in 1895 during his research with the discharge of electricity through rarefied gases. During his research, he observed that when the pressure in the discharge tube was reduced to 0.001 millimeters of mercury, a sudden electric discharge passed between the cathode and the anode, and the wall behind the cathode tube started to glow with greenish yellow color, and the fluorescent screen kept near the discharge tube started glowing. So, to stop the fluorescent screens like barium platinocyanide and zinc sulfide screens, he brought in some different substances of various thickness, but still the fluorescent screen continued to glow. So, to stop this, he interposed iron material. So, he interposed a metal plate made of iron, but still the fluorescent screen continued to glow, and the a shadow was casted. So, he found, or he thought, some invisible rays were coming out of the discharge tube, which are responsible for different kind of observations. So, he finally came to a conclusion: when a beam of fast moving electrons strikes a solid target, an invisible highly penetrating radiations are produced. These radiations are called X-rays. So, he named them X-rays because he did not know the nature of the highly penetrating radiations. So, he called these penetrating radiations as X-rays. Production of X-rays. What are the basic requirements to produce an X-ray? We need a powerful source of electron. Secondly, we need effective means to accelerate the electrons, and a suitable material to use as a target. Generally, there are two types of X-ray tubes available. One is a gas filled tube or a Röntgen tube, which was used by Röntgen, and the modern Coolidge tube or hot filament tube, which is widely used nowadays. So, this is a simple diagram how a Coolidge tube will look like. So, in this figure you could see a glass bulb, evacuated glass bulb, which holds the cathode and the anode, and a target, a cooling system, and a step-up transformer for giving a potential or for creating a potential difference or giving out a high voltage. So, a Coolidge tube is nothing but it is a highly evacuated glass tube which houses a cathode. A cathode is made up of a tungsten filament. The reason for using the tungsten filament is the tungsten has a high melting point. So, this tungsten filament can be heated using a low tension battery to a maximum of 6 to 12 volts. So, when the tungsten filament is heated, they will start emitting electrons by the process called thermi-ionic emission. So, thermi-ionic emission is nothing but when metals are heated to a high temperature, they will start emitting the ions. By this process, the tungsten filament will start emitting the electron. The tungsten filament which is acting as a cathode is surrounded by molybdenum cylinder. So, this molybdenum cylinder is again kept at a negative potential. This is because the electrons are negatively charged particle. So, if a molybdenum cylinder is at negative potential, the cylinder will repel the electron and will make the electrons to move in a narrow straight line, or they will collimate the electrons to go in a opposite direction. And the anode, which houses the target material, so which is inclined at an angle of 45 degree to the electron beam, is placed on the copper block. The target used will be mostly of tungsten or molybdenum. Again, anode should have some good characteristics like high melting point, high atomic weight, high thermal conductivity. So, high melting point means, so when they hit the anode, when the electrons hit the anode, the heat generated will be very high. So, the anode should not melt. So, it should have high melting point and it should have high atomic weight and high thermal conductivity. That means it should give out the heat to the surroundings. So, that means it should give out the heat produced to the cooling system surrounded over the anode. So, there will be a excess heat generated when the electron hits the target. So, to keep the anode at a normal temperature, it will be cooled by a running cooled water. So, usually a very high temperature of or a very high potential of 20,000 volts will be maintained between the filament F and the target T. So, this will be achieved by means of a transformer connected to the or connected between the filament and the target. So, by this process, the accelerated electrons, by increasing the potential to 20,000 volts, we can make the electron emitted by the thermi-ionic process to strike the target, and to these electrons will give their kinetic energies to the tungsten, to the target material at the anode, and highly invisible penetrating radiations were produced during this process. These rays are nothing but X-rays. The intensity of the X-rays depend upon the number of electrons striking the target, and the quality of the X-rays also depends upon the penetrating power, or the penetrating power of the X-rays also depend upon the potential difference maintained between the cathode and the target. So, that means the intensity of the X-rays depends upon the number of electrons striking the target. That means, so all the electrons will not produce the X-rays. So, the X-ray, the quality of the X-rays or the intensity of the X-rays depends upon the electrons acceleration and the potential difference between the cathode and the target. Generally, two types of X-rays were can be produced. One type is called as an hard X-ray, other one is called as an soft X-rays. The hard X-rays are highly penetrating X-rays. The hard X-rays are called highly penetrating X-rays, and the wavelength will be very low. Their wavelength will be very low. It will be around 1 angstrom. The wavelength will be around 1 angstrom. So, if the wavelength is very low, the frequency will be very high, resulting in the higher energy or in the production of higher energy X-rays. and soft X-rays or the low penetrating radiations whose wavelength will be around 4 angstroms. So, if the wavelength is high, definitely their frequency will be very, very low, resulting in the lower energy. So, for producing the high energy or the hard X-rays, we have to maintain a higher potential difference between the filament and the target. For producing the soft X-rays, a minimal amount or a low potential difference between the filament and the target is enough. The properties of X-rays. So, X-rays are a part of the electromagnetic spectrum. They are electromagnetic rays of very short wavelength ranging from 0.01 to 100 angstrom. So, we all know the electromagnetic radiations will always travel in a straight line with the velocity of light. Yes, X-rays also travel in a straight line with the velocity of light, and they are invisible to eyes. We cannot see through our naked eyes. Like our ordinary light, we can reflect them, refract them. They also exhibit the properties of interference, diffraction and polarization. So, they are neutrally charged radiations, so we cannot deflect them through an electric and magnetic fields. X-rays has the power to penetrate through certain substances or certain substances unlike ordinary light. So, they can penetrate through wood, flesh, thick paper, thin sheets of metals, and they can they cause fluorescence when they fall on certain substances like barium, cadmium, tungsten, zinc sulfide. So, these are nothing but they are fluorescent material. When X-rays fall on these fluorescent material, they produce fluorescence and they ionize the gases into their respective ions when they pass through, and they produce X-rays or they exhibit photoelectric effect when they fall on heavy metals, and they have a highly destructive effect on living tissues like a reddening of the skin, creating sores and serious injuries or the permanent injuries to tissues and glands. X-rays are widely used in various fields. They find many applications in each and every field. In industrial purpose, they are used to detect any defect in radio valves, tennis balls, rubber tires and the presence of pearls in oyster. They are highly helpful in testing the homogeneity of welded joints, insulating materials, to detect cracks in structures. They are helpful in detecting any cracks in the body of the aeroplane and motor cars. These are certain things which our human eyes cannot detect or cannot do. And they are helpful in analyzing the structure of alloys and other composite materials. Apart from this, they are helpful in studying the structure of materials like rubber, cellulose, plastic fibers by using their diffraction properties. In scientific field, they are helpful in studying the structure of crystalline solids and alloys. In analyzing the X-ray diffraction is helpful in analyzing the structure of the crystals and structure of atoms, and the structure of highly complex organic molecules can be studied. They are used in determining the atomic number and identification of various chemical elements. They find a wide usage in medical purpose. So, everybody knows this. X-rays are used to detect fracture, diseased organs, foreign materials like bullets and the formation of kidney stones in human body. We can use X-rays for the treatment of skin diseases. You can use X-rays to destroy some abnormal internal tissues, and in the treatment of some malignant cancers, and heart X-rays are used to destroy tumors very deep inside the body. and at the custom posts they are used to detect contraband goods, that is in airports and in customs they use X-ray detection to find out the forged or contraband goods that are brought from abroad or by illegal means. So the invention of